Okay, so now let's look at rhombus. Rhombus, which principle will work? If the length and the breadth are given to you, then there's no case. You just do your length and breadth. So this is the length. If the height, you see that the breadth is what is slanted. We don't want slanted breadth. Therefore, we are going to use the height. So it can be this one, right? Or it can be given to you here. So when it's given to you, use it. So it becomes length times perpendicular height. Simple, as you can see here. But if it's not given to you, you know the rule already. You use the diagonals, right? So using the diagonals becomes x times y. But when you use the diagonal, see what happens. It looks like half of a rectangle, or it's exactly half of a rectangle. Look at it. That's first principle. So this side is equal to here. This is also equal to here. This is also equal to here. This is also equal to here. So virtually it's like half has been cut off and the remaining half is given. When you use the diagonal, this is what happens. Have you seen it? So rhombus has this to work for us. Good. Kite is similar to that of rhombus when the diagonals are given or when the diagonals are used. So that means the length and breadth are not available, therefore diagonals are used. So if diagonals are used, look at the same principle working. This is supposed to be a rectangle because the rectangle is the basis for creating our formulas. Good. So this equal to here, this is also equal to here, this equal to here, this equal to here. So in principle, it's half. So half first diagonal times second diagonal. So LB as labeled over here. So that becomes for that of kite. So kite and rhombus behave in a similar way, right? They have a similar behavior. They usually use the diagonals. So the diagonals are given, use it. The length and breadth are given, use it. But with kite, if length and breadth are given, yes, so you introduce your half. Because the length is equal to the longer diagonal and the breadth is equal to the shorter diagonal. So you just introduce that. Trapezium, like I said, is it that trapezium, the A and B are the two lengths, they are not equal. So you cannot choose to use first one or second one. So let's assume that this one is 2 and this one is 5. If you use the 2, you are not being fair. If you use the 5, you are not being fair. So what do you do? 2 plus 5. Take average of it, which is half. Right? So you can take half. So you can say half. So you can say half 2 plus 5. That becomes your length. Then multiply by the perpendicular height, which is given to you. So this is how the formula must work out. So this is for trapezium. Half the sum of the two of them, the two lengths. In order to be fair, take average, multiply by the perpendicular height. So the formula for finding area remains length and breadth. It doesn't change. The changes come in of the names, making it height instead of breadth is about when it is slanted. And the half, introduction of half also comes in when you need to take average of something or it looks like half of a circle. So trapezium looks like these are not equal. So we take average of it, of the sum of them to get it. All right, triangle, last but not least. Triangle also looks is half of a rectangle. So you draw like this. Let me draw it well. Go this way, go that way, go that way. So just like a rectangle, half of a rectangle or a square. You see that this is equal to that. This is equal to that. Therefore, it's half. So half, and we call it base, and we call this height. So half base times height. That is the origin of the half, introduction of the half. So triangle has half. You need to introduce half because half a rectangle. Trapezium, you need to introduce half because the two lengths are not equal. So we take average of it. So we introduce half. Kite is half of a rectangle when the diagonals are used. Rhombus is half of a rectangle when the diagonals are used. So these are areas where you introduce half in their formulas. All right. So on that note, that's it. This was simple to understand. So let's look at how the examiners frame the questions for you. This is the image. This is the picture. This is a circle. Area of a circle is known. We have just generated it, pi r squared, and we saw how we generated it. It is proven. So you know anything that you need to memorize, right? I can pick it. But I can get a general principle to go by it. It's very nice because circumference equals what? 2 pi r, isn't it? Good. When you raise the 2 to become like a power, it becomes pi r squared. Simple. So you can easily remember. So you remember that area is measured in square units. So the one with the square is the area, and the one with the 2 down. So when the 2 comes and become perimeter or circumference, is it not nice? So you can use that to recall. That's perfect. The question says in the diagram, O is the center of the circle with radius 5 centimeters. So the radius is 5 centimeters. If the angle POS is 60 degrees, what is the area of the shaded sector? Now, the question is asking for the area of the shaded sector. Because if he asks for area of the circle, which you know already, it's not so simple. Area equals what? Formula is what? Area, let me write it this way. Area formula equals pi r squared, isn't it? You know. But not area of the full circle. He wants area of the shaded portion. Only this. The shaded portion here. And mathematics, when you talk about portion of something, it means it's a fraction. It's a what? It's a fraction. So he wants the fraction of this. What can you use to calculate fraction of something? Right? Of a circle, especially. So with a circle, we use the angles. If you want the fraction of a circle, use the angles. So if here alone is 60, that means the shaded portion should be what? 360. Sorry, 300, because you know that that is 360. Total angle is 360. So the formula becomes area equals fraction, because I'm using theta because we don't know. We can also use x. So the missing area is what? So theta over 360. That's a fraction of the shaded angle. Multiply by the formula. Multiply by the area formula. That's all. You want area of. So if you want perimeter of the shaded portion, you use what? 2 pi r. You multiply by 2 pi r. Simple. So the fraction component is very important. So let's calculate the theta. What will be theta? Yes. What will be theta? Theta equals what? Let me write it up here. So let me use it. Theta will be equal to what? 360 minus the 60 equal to 300. Isn't it? Because this alone is 60 and the total angle is 360. So we calculate theta by just doing this. This is a simple work to do. So now let's calculate our area. So area is equal to the fraction, which is 300 out of 360 multiplied by pi is what? 22 over 7. But look at the answers. All the answers contain pi except one. So let's assume that they are all containing pi. So let's see. So pi will be there. We are not going to dissolve the pi. Multiply by r squared, which is radius squared. And the question said the radius is 5, so 5 squared. So let's put this in calculator. So 300 over 360 times 5 squared. What will be the answer? That is it. That is exactly what the examiner is expecting you to do. So when the question had asked for area of the unshaded portion, that means our fraction would have been 60 over 360. So the triangle involved is what you use to calculate the fraction. Fraction is out of total. So that's it. So let's calculate it and see. So let's go to our calculator and get it there. All right, calculator. Let's go to our calculator. So my fraction is 300. Then xy, you press the xy sign. That gives you a fraction. So 360. And make sure you press the forward arrow to take it to the center before you put your sign. Multiply by pi, but the pi is not dissolved, so we don't use it here. When you finish, you attach it to the answer in case that is the correct answer. So the pi is not dissolved here. Multiply by 5 squared. 5 squared. 5 squared is, you press the s squared, it will come. This is the answer. But all the answers are in fraction. So what do? You press equal sign and press SD. SD takes you to improper fraction, which is 125 divided by 6. You want mixed fraction. So mixed fraction, you press Shift SD. 20 whole number, 5 over 6. 20 whole number, 5 over 6. Pi. It means the pi must be there. If it is so, you can see the answer clearly over here. So it's B. 20 whole number, 5 over 6 pi square centimeter is the correct answer. All right. So on that note, I think that's the end of length and area. You can, I will say, you can answer some of the questions submitted to you. Try your hands on it. Submit. Do your best. Just apply the principles. Apply the formula for area, length and breadth, length and breadth, length and breadth. Where you need to introduce half, you know the shapes. Where you need to do something else, you do so. So take note of that. All right.